Hey everyone, this is Matt with Learn Everything About Design, and in today's video, we're going to be going through the process of using Auto Freeform tools in QuickSurface Lite and QuickSurface Pro. Now, these videos are recorded for the purposes of a webinar for QuickSurface, and the full videos walking through the entire process are the ones that we're going to see here on YouTube. So if you want to follow along, I will put a link in the description to a Fusion file that will have access to the mesh, so you can export that mesh and upload it into QuickSurface if you want to walk through the process. But what we're going to focus on today is how we can use QuickSurface and Auto Freeform tools to be able to replicate complex geometry. Now, the part in question here is this KTM bar clamp. This is a part we've seen on the channel several times. We've scanned it with many different scanners, and we've actually done a series on reverse engineering it in Fusion 360. But in this video and this webinar that we're doing here, we're going to walk through how to use the QuickSurface tools and talk about the differences between QuickSurface Lite and Pro when it comes to some of these tools and options. So if you're looking to figure out whether or not Lite or Pro is the right fit for you, and you want to see how the process works for reverse engineering a part like this using the QuickSurface tools, then hopefully this content will help. So to get started, the first thing that we need to do in QuickSurface Lite, which is what we have currently, is import a mesh. Now, this can be done a couple different ways, but the main way that you would do it is by simply selecting Open and then bringing in your STL or your OBJ file. Now, an STL is typically made up of just triangles, where an OBJ file can also be a quad mesh. In this case, it doesn't matter because the starting point here is actually just triangles. So STL is the file that you're going to be working with. Once you import a mesh, the next step in that process is to do any review or cleanup of the mesh. Now, this mesh is not bad. This specific one was scanned with a Creality Raptor Pro, but you can see that there is some orange peel. Now, part of this is because of the limited tool set and features that we have in the Creality scan software. So when you bring a scan like this into something like QuickSurface Lite, we typically want to go into our scan data and talk about doing things like reducing the noise or potentially reducing the number of polygons. Now, if we click on and select the mesh object here, we can see that the number of points is about 900,000. Number of triangles is creeping up to about 2 million triangles. Way more than we need for a part like this. So the first thing that I would do is I would go through the process of reducing the noise and reducing the polygons, getting to a lower polygon. When we're talking about which one of these tools to use first, part of that comes down to, again, the number of triangles that we're dealing with and what the end goal is. So we're going to get started first by reducing polygons. We can pick a percentage value. We can see what the target number is. So if we go down to 25%, this is going to take us from about 1.8 million to roughly 500,000. We can preview this. What I'm going to do is I'm going to show the mesh wireframe. So if we zoom in, we can kind of see what we got here. You can see there's a lot of high and low spots. And if we preview this, we can see that the end result is greatly reduced. So we still have a higher density in the corners where we have fillets, and then we've got lower density on the sides. So in reality, we could probably even go down lower than this. So let's try 10%. This is going to take us down to 181,000 triangles, and it still looks like we've got more than enough detail on the fillets. So you can see with this algorithm doing the polygon reduction, it's leaving quite a few triangles in the corners. I'm going to also keep the original mesh. While this isn't required, if we say OK, what this does is it leaves us with the original mesh, which is the 1.8 million, and then we have a reduced mesh. So again, we took it down to 10%. This means that we're now at 181,000 triangles. From here, there are some potential issues that you might find. When we go down this low, you can see there are some spots that maybe are inconsistent. This could potentially lead to problems downstream. So the next step that I would do is reduce the noise. We have an iteration slider, and essentially what's going on here is it's going to look at the angle between the triangles, and then it could gradually adjust those so that they are smoother. Now, for areas where the triangles change more drastically rather than a couple degrees, we're talking about 3+ degrees rather than somewhere between 1 to 3 degrees, those are generally areas where the boundaries are going to be preserved. So once again, I'm going to show the mesh wireframe. I'm going to zoom in a bit and preview this. So when we preview this, what you'll notice is that the triangles start to normalize. So instead of having a bunch of small triangles and a bunch of large triangles, it starts to make the smaller ones bigger and the bigger ones smaller, and they sort of move around. We're going to do this again, going to keep the original mesh, which means that now we've got a version of the mesh that is just that reduced number of polygons. And then we've got a version of the mesh that's reduced but also smooth. What we can see on the screen here, the yellow is the selected mesh, which is the unsmoothed version. And then if we select the smooth version, we can see that this is a much smoother result. We do have to be a little careful that we don't go down too far and start causing problems. Again, losing data or potentially having issues in the mesh. But again, what we did here is we took it from the original, which again had almost 2 million triangles. You can see there's a lot of noise in it. And then when we go down to a version that's only 10% or under 200,000 triangles, we still have maintained the integrity of the scan, the data that we're working with, but we have a much smoother version here. Now that we've processed the mesh, we need to start thinking about a couple of the next steps. These are things like extracting primitives, constructing a symmetry plane, and figuring out how we're going to align it to a coordinate system. Because right now, if we look at this from, say, the top, that's obviously not aligned. Whenever we have scan data, typically what happens is the first frame of that scan is going to be the orientation. So scanners have IMUs built into them. So they'll know kind of their position relative to space. So if that first scan isn't perpendicular to, let's say, a tabletop, then the scan's going to be off. So this one here is just, it's just kind of off. It's not perfect. Now, the part is only symmetric, in this case, roughly along the y-axis. You can see that the bolt position is offset one direction. And when we look at it from the side, you can also see it's offset. And really the reason for this is because this bar clamp on KTM triple clamp has multiple mounting positions. And depending on how you rotate it, you can actually get to a couple of extra positions of the handlebars on the motorcycle. So what we're going to do before we align it to a coordinate system, I'm going to go to Construct, Symmetry Plane. And we start this by simply left-clicking on one side, left-clicking on another to draw a line. Now, the instant results are not great. You can kind of see that we should be able to see the mesh over the entire thing. So we're going to start by selecting Rebuild. Now, Rebuild will go through the process of trying to analyze and come up with a true symmetry plane from our starting point. We can turn an analysis on, and this looks like a pretty good result. You can see it's slightly off here and here, but for the most part, we're seeing a lot of green. So I think this is a pretty good result for a symmetry plane. The part may be partially worn. It may not be truly symmetric. I mean, I believe it is, but I obviously don't know that for sure. But I think that this looks pretty good. If we want to, we can do some manual adjustments to try to get it closer if we think that we can do that. So for example, by rotating that a little bit, you can see that we have gotten a bit closer. And I think that's okay. So I'm going to select Create. And what this did is it now created a symmetry plane right in the middle. And we can use that plane during the alignment process. But I do want to extract a little bit more data from it before we start to pull out the mesh or the areas of the mesh that we're going to use for our Auto Freeform. So we're going to go to Extract Primitives. I'm going to start by using the Magic Wand. The Magic Wand is going to allow me to select an area. And based on this slider here, which is going to be the number of degrees between triangles, I can then have it create primitives. It's always a good idea for us to turn on the analysis and see how close it is. Now, keep in mind that while this is a bar clamp and it's meant for a truly cylindrical handlebar, the way that these things work over time, we are clamping down on an aluminum bar, which means that we're getting a lot of high pressure right in the center, and it could potentially deform over time based on wear, based on the handlebars. So a true cylinder may not exactly match the scan, but we're going off of design intent in this case. So I'm going to create and stay. I also want to create a plane on the top, but I'm going to select both sides, create a plane. You can see it's all green there, so that looks good. We'll create and stay. I'm going to create a plane on the bottom. Again, I'm going to select both sides. We'll take a look at that. One important thing to note, and this is an important thing no matter what you're doing with in terms of aligning to a scan, we always have to think about perpendicularity. And what I mean by that is right now, all the planes that we're creating are not constrained, which means that we're at the mercy of the mesh itself. That means that this plane and this plane down here are not necessarily parallel. If I try to do undo to roll that one back, these are still selected, so we're going to select create a plane. But what we could do is we could select an option to make it coincident to another plane. So for example, we could make it parallel to the XZ plane, or we could make it parallel or perpendicular to plane 1. So for example, parallel to plane 1 would ensure that the top plane and the bottom plane are truly parallel. As we're trying to extract data from meshes, this is important because even with an extremely accurate mesh, we could be half a degree or 1 degree off. And while this really might not matter for some parts, in other like mechanical parts like this, you may find that things like extruded cylinders or extracted primitive cylinders could be off that number of degrees. So if you're going to machine a part or use the data downstream, again, we have to go back and think about things like design intent. The bottom of this should be perfectly flat, and it should be parallel to that top plane. So what we're going to do is make it parallel, create and stay. Next, I'm going to extract a cylinder from inside of here. We can make sure that the cylinder right now, it's unconstrained and it looks pretty good. But we could say that the cylinder needs to be perpendicular to plane 2. While it still looks green in there, you can see that looks pretty good. We're going to go ahead and do the same thing up top. We'll create a cylinder here. These cylinders can be used for alignment to a coordinate system, but they can also be used to remove material or geometry. So again, we want to make sure it's constrained, perpendicular to plane 2. We'll create and stay. And that's probably going to be good enough for what we're doing. So I'm going to go ahead and close that. So right now we've got our symmetry plane, which should be right in the middle. These two planes here, when they were created, theoretically what we should have done is made them perpendicular to our symmetry plane. But again, the symmetry plane was kind of not necessarily perfectly accurate. So what I'm going to do instead is I'm going to align this to a coordinate system. I'm going to use one of the cylinders, cylinder 3, for example, to set my coordinate system. I'm going to flip it so Z is in the vertical direction. Zoom in so we can see this a bit better. And for a perpendicular reference, or for the direction of X or Y, we could use cylinder 1, and that will drive the axis direction of X or Y, depending on which one we want. In this case, I want it to be X, so I'm going to flip that around. And then I want to make sure that Z is flipped so it's up. So X is going left and right, which should be on our symmetry plane. At this point, we don't really need another reference, but we could use things like plane 2 if we wanted to push the coordinate system all the way to the bottom, for example. That's really comes into play when we start to export this to a CAD system. For what we're doing here, it's not really going to have too much of an impact on us. We also want to make sure that we say that we want to apply it to all features, which means all the planes and primitives we create will get moved to that new coordinate system, and then we can close. So now if we rotate this around and look at it from, let's say, the side or the top, we should have a really good orientation or view for this geometry. So the next step in this process is really where it starts to change between QuickSurface Lite and QuickSurface Pro. And this is going to be extracting the mesh data. So what we're going to do is I'm going to save this design at this point, and this is going to be our starting point for both QuickSurface Lite and QuickSurface Pro, because up to this stage, everything should have been the same. The symmetry plane is the tricky one because extracting a symmetry plane is, there are some options to use symmetry planes when we're using things like Auto Freeform. Those aren't available in Lite, they are available in Pro. So the symmetry plane right now is created, but it's not really going to be super useful to us in Lite. But again, I'm going to save this as our starting point for both because there's no reason to redo that portion of it. All right, so now that it's saved, the next step in our process is to begin to extract mesh data so that we can use it for both primitive creation, but mainly for Auto Freeform. When we're talking about QuickSurface Lite, it is important to note that we don't have access to tools like Boolean. We can't create a bunch of solid bodies and combine them together or subtract. We can export those solid bodies to another CAD system as intermediate formats like a step or a parasolid. That data can then get used in, say, Fusion so that we can do those Boolean operations like combine, join, intersect, cut or remove, those things. When we're talking about QuickSurface Pro, however, we can do those directly in here. So while they're not going to be extremely helpful for us here, they are going to be helpful for us later in Pro. So for right now, what we want to do is I'm going to hide the planes and the cylinders. I'm going to go into this last scan, the smooth and remeshed one. I'm going to go ahead and edit the scan. The main thing that we want to do is pull out the areas that we're interested in. So I'm going to use my magic wand. I'm going to select the side of this, and I'm going to begin to increase the angle until I get most of the mesh that I'm interested in. So I don't want the bottom faces. I don't want the top faces. I really want to go, kind of up to where this fillet is. So I'm going to reduce this a little bit because I don't want too much. And once we're here, I'm going to start to use this option to enlarge the selected area. Now, you might find that this goes a bit too far, but this should be able to grab most of what we're interested in. You can kind of see that we're getting to the point where it may be problematic. We're rolling over the fillet. That's okay because we do have to delete or remove some of it. So from here, what I'm going to do is change this to my freehand selection and make sure that we are not selecting through, turn that off. And then I'm just going to grab areas that were missed. I don't want any holes in the data. So anything that was missed, probably due to angles, I'm going to go ahead and just grab that. And it looks like we got everything. Once it's all selected, we're going to select copy and create. There are some additional tools in here that we're going to explore in Pro. For example, we can split mesh with other solids, surfaces, or meshes. And this is going to be the way that we begin to extract and process this in Pro. In Lite, we don't have those tools, so we have to work with what we have. So now we've got the smoothed mesh as a complete mesh body, and then we've got just the outside section that we selected. Now we can take that new selection and we can edit that. The next step that we want to do is we want to start to remove areas. So for example, this boundary here, we want it to just be a nice smooth line. So I'm going to go to a side view. I'm going to select through, and I'm going to use the line option here. I'm just going to click on the left side and hold down and just draw a line over to the right, and then select delete. And I'm going to do the same thing up top because we don't want it rolling over where the fillet is. And we'll select delete. I'm going to use the circle tool and see if I can't get this to be roughly right. That looks pretty good. And we'll select delete. And then I'm going to roll this around, turn off select through. We're going to do the same thing with the bolt holes. So I'm going to try to cut that out. And then we'll go over here and we'll do the same thing, maybe right there. And we'll delete that. All right, so when we did that, it left a couple of dangling pieces. If we take a look at our dialog box, it now says individual meshes 6. So we'll select edit. We're going to left click on the main body here, and we'll use this one option, which is the leave selected only. And that will get rid of the other 5 extra little pieces that were left behind. The next step is the holes. So with the holes, one thing that we want to note here is that we want to fill these, but the boundary of these holes is pretty jagged. So if we don't get a good result here by selecting them and filling them, we may want to go back and expand the holes. So if I do undo and I select this, we can use this expand option, which will basically take it out one extra triangle away, and that might get us a smoother result. There's a tiny little hole here that we'll deal with in just a second. Let's go ahead and fill the other one here. So again, select the boundary. I'm going to expand it 1 and then fill it. And that looks pretty good. So you can see it still says that we've got 6 holes. What I'm going to do is use this dimension right here and measure the size that we're working in here. It's going to put it, it's roughly about 1 millimeter. I'm going to hit expand, and then I can click on that and fill it. So sometimes we want to go through and we want to find where these little holes are. You can see there's one here. Click that and fill. And I'm going to go ahead and expand. Looks like we've got a couple more. We'll fill that. And as we go around, it just says 2, so that's the top and bottom. So now we can say back. Next step in this process, I'm going to select Edit, and we want to clean up the boundary. This is another thing that Pro can do inside of the Auto Freeform tool that we don't have available to us in LITE, but we can manually clean up the boundaries before we try to create a freeform body. So what I'm going to do is add an anchor point, and I'm going to put an anchor point right here, and then I'm going to go back and select this edge and clean it up. So the anchor point is going to prevent the edge from sort of disappearing too much in that area. On the top side, if we try this, let's go ahead and I'm going to move this down. Let's go ahead and clear all the anchor points. I'm going to select this entire edge and hit smooth. And it looks like we got a pretty good result without anchor points. That's just something that you need to play with on your specific model. You might find that you need them. You might find that it may do okay without them. But again, when we're talking about using QuickSurface LITE, this is going to be one of those steps that we have to do, which in QuickSurface Pro, we can actually create quite a cleaner border using a different type of trim method. So now that we've got this all set up, the next thing to do is to start building out our solid model. So we're going to build out the solid model a couple of different ways. The majority of the bodies, we're going to be able to use surface and solid tools that we will have to export to Fusion as an intermediate file. And for this portion of the design, what we're going to do is use Auto Freeform. Now, Auto Freeform, there are actually 2 different algorithms to calculate the Auto Freeform. There's Basic and there's Feature Aligned. Feature Aligned is only available in the Pro version. It gives us a different result. It opens up different options, things like using symmetry, having it be feature aligned, things like that. The results from the basic algorithm that happens inside of LITE, it can be hit or miss. It is going to depend largely on the bodies that you're working with. So what we're going to do is we're going to leave this target quads at low. We're going to start at low and preview this and just take a look at our results. So overall, the results actually look pretty decent. We're not going to see the freeform edges until we finish the surface. You will notice that there are a couple areas up top where it's dipping down. We can always try to go to medium and regenerate this, see if it looks a little bit better. Generally, what's going to happen is as you add more faces to this, 1, the calculation times are going to get longer, and 2, if you're adding way more faces than you actually need, the results are going to start to degrade. So if you don't need to have 2,000 or 5,000 quads to make this shape work, then you likely shouldn't do that. We can also use the analysis to see how close we are to the surface. So from here, if we go to medium and preview it, you can see that we're still a little bit off on that rounded edge, but everywhere else looks pretty good. Now, if we go to fine and preview this, with more triangles, we start to get closer, but I think that for the purposes of this part, I would be okay with the results from medium because I'm more concerned with the boundary and less concerned with how close this edge is. So I'm going to say okay. And now that we've got our results, I'm going to double click on Auto Freeform and take a look at the results. So you can see there are a couple of red dots here. These are irregularities in the surface, and we need to just simply click this red area, and what that'll do is it's going to move them as star points to one edge inward of the design. With the basic algorithm, you're going to find that you will likely need to make some manual adjustments. You need to make sure that snap mode is on, which means that we are snapping to the mesh. So I'm going to kind of work my way around, and I'm just going to pull these maybe a little bit closer. Keep in mind that as we get closer to these edges, we could potentially run into issues if there are surface irregularities. The next step for me, I'm going to hide the mesh that this is snapped to, and I'm going to bring back the full mesh so we can kind of see how far these edges need to go. And I'm going to start with the bottom one. I'm going to double click on this bottom edge. I'm going to turn off snap mode, which means it's no longer snapping to the mesh. And I'm simply going to pull this straight down. Now, with this part specifically, That bottom section is extruded. So it is a true profile that is just extruded in that Z direction. The same thing is true with the top of this design. If we go to a top-down view, this shape is extruded straight down, and same thing with the bottom, and then there's just sort of this blend that happens in between. So I can get away with extruding those areas without actually having to snap it to the mesh. The same thing is true here. I'm going to double click and pull this up just to make sure it's above that fillet. I'm going to go to the other side, do the same thing, double click, and pull this up in Z to make sure that it's above. Now, what we want to make sure is that where we're going to cut this does not end up close to edges or vertices that are on our freeform model. We want it to be fairly clean, so we want to make sure that they're high enough above. For this edge here, so what I'm going to do is I'm going to double click and grab this. I'm going to go to extrapolate, and what this allows me to do is select this edge and pull it out normal. What you're going to find is you will run into issues like this here. The first thing that I generally try is to use the smoothing brush and allow it to kind of smooth those points out. The smoother this border is, the better chance we have at things like fillets working. So areas where they start to bunch up, I'm just going to manually do this. You can always turn on analysis and see how close you are to the original. So if you're worried about getting too far away, you can see everything looks pretty fine until we get to that fillet, so not a big deal. I'm going to rotate around to the other side and go back to my tool here. We're going to double click, go to extrapolate. Remember, we're not snapping to the mesh, so I'm going to pull that in. And again, you can see it's starting to overlap there. So let's go ahead, let's turn the analysis off, go to a smoothing brush. And again, just try to normalize these so they're not bunching, kind of get them to spread out a little bit. Do that right there. There we go. All right, so again, you can turn the analysis back on. Make sure that you're not having any problems like this where it's starting to kind of get away. If it is, you can turn snap back on, use smooth, and kind of go over that area, kind of make sure that it's clean. I think overall that looks pretty good. Let's turn analysis back off, and we'll close this. All right, so now we've got a freeform surface. The surface can be trimmed by other features. So for example, we've got planes. We can select, let's find this top plane right here, and our freeform surface. We can select those and trim them with the Pro. But when we're talking about using QuickSurface LITE, we don't have access to some of those tools. So things like cut and trim. So for example, if we select trim, this is a Pro only version. What's important that we understand here is that our surfaces, our primitives that we create, things like the cylinders, all the features that we need, those should all overlap our surfaces. So for example, right here, the cylinder, probably need to extend it out on both sides. It's not quite long enough, just to make sure that it extends past our surface. The top plane gives us a good idea of where that top surface needs to be. The bottom surface is there as well. And if we export the primitive features and we export the mesh, you have to do them separately. Those will all be aligned when we bring them into our CAD system. So just make sure that you extract enough references. If you need a secondary plane, so for example, this bottom face here, we can always go and extract more primitives. So we'll grab a plane, check the analysis. If we need to make it parallel to, plane 2 or plane 3, create and stay. And again, if we need to pull out any additional references, we will still have the mesh. So we can always use that mesh if we want to, but if we need to pull anything else out, we should do it now. We do have the ability to create a 2D sketch in the LITE version. So for example, create a sketch and extract primitives. I'm going to grab a fit line. So I'm just going to go from here, build a line, and maybe here. I'm going to hold down the Alt key, which will temporarily disable that selection, and then come to here because there is a little bit of a jagged area. And then I'll just drag these out to the right, out to the left, and we'll do the same thing over here. And what this does is it gives me just the features I need, right? So I can connect those I don't really care if this is square. All I really care is that we've extracted where those edges are. And what we can do is we can extrude that as a solid. So this is going to come down. This one will be 0 from that plane. Now, this is another area where having Pro is a benefit because we can actually hold down Control and snap to the mesh. Whereas when we're using the LITE version, the only thing we can really do is we can kind of eyeball where that is. Now, of course, in reality, we're going to extract that plane. So the best thing that we can do is just extend this past. And when we export things to our CAD system, we're going to use that bottom plane to cut that where it needs to be. But again, in Pro, we have very different options because we can snap directly to the mesh. So we're in exactly the right place. So I'm going to bring my freeform back. And we've got our primitives, we've got our cylinder up top, we've got the 2 cylinders on the inside, we've got the planes on the top and the bottom, we've created that primitive. Really the only thing missing is the location of these 2 holes. So again, we create a 2D sketch. I'm going to go ahead and pull this up and just put it somewhere where we can actually extract data. Now these are obviously threaded holes. And in reality, those would get threaded later on, so we would just need the appropriate sized hole. So all I'm really going to do is extract a circle. So again, select everything we need, apply a circle there, and we'll do the same thing over here. And the main reason for this is because we'll create some primitives, and then we'll know, basically we'll just know their location based on the mesh. So again, just create some primitives so you have them. This one on the backside here doesn't really go all the way through, but for the purposes of extracting these primitives, I would rather have more information, and then I can change its height or modify it later once all that data is in CAD. So what I'm going to do here is I am going to save this file, and then I am going to export the solids and then export the mesh bodies. So again, the mesh bodies we've got a couple that we've sort of defeatured so that we could do the Auto Freeform. We've got the original, we've got the one with the reduced polygons. But what we do from here is we're going to go to File and we're going to say Export Model. And I'm going to call this, we'll save it as a step file, KTM bar clamp webinar LITE. Keep in mind that there are differences between the different file types. So if we do a step file and we bring this into Fusion, for example, each of the individual bodies will be their own component. We also have IGES files that we can use. There are a couple other formats in here, but mainly the 2 that we're going to focus on are step or IGES. So I'm going to use an IGES export for this. Note that we've got create surface for every freeform face if we want. That's not a great option because every freeform face could potentially be dozens, if not hundreds, on that freeform body. Map Z to Y axis, we're going to leave that alone, and then we'll save this. The other thing that we need to do is export the meshes. So again, from the QS menu, we're going to say export scan data. I'm going to save this as an STL. I'm going to call this KTM bar clamp aligned LITE with LITE meshes. So that way I just have that good reference. All right, so now that we got that, I'm going to go ahead and save this, and I'm going to open up the version of this project from Pro because we're going to come back to that and we're going to talk about how we can do it differently with Pro. But now let's go ahead and hop into Fusion and we'll take a look at what that data looks like when we bring it in. All right, so in Fusion, when we open the IGES file, we have a component that contains all of the bodies. You can also see it's treating everything as unstitched surfaces. So this can be a bit tricky to deal with. It's a little different if we use a step file, but again, every body is going to be as its own component. So the main thing that we need to do with this is go to our surface tools and stitch them together. Now there are some options if you are working with history capture off. So for example, if we go down to this gear icon and do not capture history, this actually opens up some additional tools for us. So you can see here there's this validate option. And what we can do is we can validate bodies. I'm going to select all the bodies. We've got a repair option, which talks about gaps and healing. We have a different checking level, basic and standard, but we're going to go ahead and just say okay. And what this should go through, this should go through all the bodies that we have selected and try to stitch ones together that make sense. So for example, the primitive cylinders on for where the bar goes and for these holes and for this bottom, those obviously were originally solids. So using that tool keeps us from having to do all of that manually, but we just have to turn the history off first. So we've got this solid body, which is I'm going to call this one C-bore. And we've got this one, which is bolt. I'm just call it bolt through. Just name it something that makes sense. These two will get joined together. This one here is for the bar area. And then these two are for bolt holes. So I'm just going to call this bolt 1. I'll call this one bolt 2, just so I can easily know what they are. And then the bottom one is that primitive to remove for the sort of bottom recess. So I'm just going to call this bottom recess. And the other piece here is obviously the main surface that we want to take a look at. Now, if I turn the edges off with Control and 4, we can see that there are certainly some wrinkles or some inconsistencies that are happening here. And this is what we saw when we were in QuickSurface and we were playing around with low, medium, and high number of faces. And we saw how, for the most part, it matched up here, but down here it didn't. Now, this is going to be one of the big differences with the basic algorithm that's in LITE and the algorithm that you get in Pro. So we're going to see a big quality difference trying to use a tool like this when we're trying to wrap a part. So when we get to that, we'll show the difference. But for the purposes of this, let's go ahead and talk about how we can build this into a solid body. One thing you'll notice is that we don't really have planes. The planes didn't come in as bodies that we would need to work with. So unfortunately, the way that we need to get around that is by creating surfaces from those planes. QuickSurface itself will be able to use those planes to cut things, but it didn't get brought in here. But what we're going to do now is we're going to right click and capture design history. Then I'm going to go to mesh and I'm going to insert a mesh. So what this should allow me to do is just pick up on the mesh. It should be aligned exactly the same. So you can see now we see where the mesh is. We see exactly where all of our features are, and we can start to use that to build this out as one solid body. So let's go ahead and hide all these solid bodies for now. And let's talk about how we would do that in Fusion. So in Fusion, in order to get a plane on any of these faces, we have to do a trick by going into direct editing. We can create planes from 3 points. So for example here, and we can create them by snapping on the mesh. But what you see here is it's not really doing a great job of picking up points. So we'd have to zoom in and make sure that the points are actually on the surface that we're working on here. You can see that it's not really giving us a good indicator where we're selecting these points. Some of the other points where they're actually coming from is actually the surface here. So in order to use the mesh, we have to go into direct edit or select the body that we want. And then we'll go to our planes, create from 3 points. And now we can select points on top of the mesh to create a top plane. So we'll say, okay. I'm going to rotate this around. I'm going to do the same thing on the bottom, knowing that we're going to cut this section out because we brought a primitive over. So again, construct plane at 3 points. I'm going to go ahead and rotate this around, try to grab 3 reasonable points to create a plane. We don't have an option to keep it parallel to the top plane, so we just have to hope or assume it is okay. And then we can finish direct editing. So now on this plane, we're going to create a basic sketch. I'm just going to create a big rectangle that's bigger than my part. And as a surface, I'm going to just turn that into a surface patch. All right, I'm going to do the same thing on the top plane. We'll right click and create a sketch. I'm going to make a rectangle that is bigger than my part. rotate this around. We'll patch that. And we're going to bring back the bar area. All right, so what we have at this point, I'm going to hide the mesh, but what we have at this point is 3 surfaces. We've got this top, this bottom, and then the freeform surface that we brought over. And then we've got this cylinder, which is a solid. And as long as all these things overlap, what we can do is we can use this boundary fill tool. We need to select our tools, the cylinder, plane, that surface, the surface here. And then we're going to select the cells that we want to keep. All right, so we want to keep this cell in the center, and we're going to say OK. Now, what this should do is it should build out a new body for us. And if we hide this, what we should be left with, let's hide the surface as well. We should be left with this thing right here. All right, so now we can go into, let's say, this bolt area and this counter bore. Go ahead and hide these, make sure that they are touching. So there is a rounded corner, so there's a fillet between these. So what we need to do is use some tools like press pull. And we're going to extend this out, and we'll say OK. And then we can join these together. And then we bring our main body back. We can use the cut portion of this, select the main body, and then remove this. Actually, you know what? Hold on. It doesn't go all the way through, so let's do the same thing on the bottom. So press pull is the Q shortcut key on the keyboard. You can also get to it from right here on the modify tools. And assuming that goes all the way through, now we can use combine, and we want to remove that from the center. All right. We've also got this bottom recess feature. And we created a plane on the bottom, which should be exactly where that is, right? So if we go into our construction, the plane on the bottom should be exactly where that surface is. So we should be able to use combine and remove this. And we'll need to do some small fillets in these areas to round them off. And then the last thing we have is these 2 bolt holes. All right, so this originally didn't go all the way through. It kind of ended on this step. So what we're going to do is we're just going to bring that up. Kind of ended like that. It didn't punch all the way through. And then once again, we can use combine, and then we'll get rid of these 2. You can obviously extend that a little bit further. When it gets threaded, the threads are a little smaller and it cuts through, but you can kind of get the idea. And then we can go back and do things like add fillets, probably about a 1 millimeter fillet. We'll add it to here and round those off. And then hopefully we can add a fillet to here, probably a bit smaller. Hold down Control, and we'll add it there as well. And then the last thing is these had a very tiny fillet on them. And if you want to, you can add one in the corner there. It wasn't really a fillet there, but it wasn't exactly a square corner. Looks like there's some problems around the corner, so make it a little bit smaller and say OK. And that's the process. Now, obviously, there are some potential hangups because of the algorithm for Auto Freeform that makes this possible. It is better in Pro than it is in LITE. It is still possible. There is a limit to what you can get out of it. Obviously, we can increase the number of faces and try to get it closer. But once again, if I hide the edges, you can see that it definitely did not adhere to certain areas. So just a quick recap. The differences between LITE and Pro really shine with these types of workflows. And what I mean by that is the algorithm for Pro to create a freeform body, an automatic freeform body, is much better. The tools that we're going to have to extract portions of the mesh and use them as a freeform body is cleaner. It's going to give us a cleaner result. We also have all of the CAD tools available to us directly in QuickSurface Pro to where we don't have to export the surface bodies and the mesh bodies directly into Fusion to make all that work. So now that we've walked through that process, we've seen it with LITE, we can see the results, we know how it works and what we can do to get an end result. Let's go ahead and hop back into QuickSurface Pro, and we'll take a look at how to do that with those tools. All right, so now that we're back in QuickSurface Pro, we're going to talk about, again, at this point, we've already extracted some primitives, we've aligned it to coordinate system, we built a symmetry plane. All of that is going to be the same process, whether you're using LITE or whether you're using Pro. Where we start to run into some differences is that with Pro, we get extra tools for extracting data from a mesh in terms of cutting and cleaning things up. We have the ability to combine all these things together, solid bodies, surfaces, planes, do all that CAD work directly in Pro. And we also have a different algorithm for Auto Freeform that gets us a much nicer result. Now, remember, the results are always going to be based on the mesh bodies that you use. So if you've got a bad mesh, then you're going to get a bad freeform body. We're going to use the exact same mesh body that we used for the LITE version, so we can see back to back what those differences are. All right, so the first thing that we want to do in this case is we want to build out a sketch and extrude a surface that's going to allow us to cut this cleanly. All right, so we're going to do a 2D sketch. We are going to pick the XZ plane, and we're going to create a new sketch. So from here, we're going to extract some primitives. I'm going to do a fit line right there. I'm going to do a fit circle. So I'm going to start to select some of this. I'm going to hold down Alt, which is going to temporarily toggle that off. I'm going to come over here and then allow it to create that circle. All right, so we're going to go back. I'm going to extend this line all the way out, all the way across, and we'll come over here as well. And then we'll use the trim tool to get rid of the stuff on the inside. Again, we've got a primitive displayed right now, so if we hide the primitive, we'll be able to kind of see what's going on. Get that extra little bit there. If you see these endpoints are red, what that means basically is they are not connected. So this one's free over here. So if you happen to see these inside ones as red, that means that you just need to go back and trim a little excess off. So what we have here is we've got a sketch that is exactly where the top is. What we can do is we can offset, we can build a surface and we can offset it. So I'm going to use this tool here, and I'm going to basically pull this down, pull this one down, and I want these two to be collinear. So we've got a collinear option, and then I'm also going to pull this arc out. So go ahead and drag this out and drag this out. Now what we could have done is we could have shown the mesh and sort of manually drawn this as well. So if we don't want to extract it directly from what we have here, and go ahead and delete that. What we could do is manually draw, let's just say, let's do a circle there, bring it down, and make sure that it's outside of that fillet. And then over here, I'm going to draw a line, make sure that it's below that fillet, and then we'll use our trim tools again. So again, very, very similar process, but instead of extracting directly from the mesh, we can just eyeball it, and it's going to be good enough for what we're doing here. So we're going to extrude that as a surface, make sure that it goes all the way through. We'll say OK. It says new solid in the dialog box, but it's a surface, and I extend it out more. It's got to go all the way through. All right. And we kind of need to do the same thing on the bottom as well, or we need to create a plane. I could use a plane, but in this case, let's just go ahead and we'll just use the same process. So I'm going to show the mesh, and basically I don't want the freeform body to have to conform to this, so I'm just going to basically come to about there. We'll extrude that out, make sure it goes all the way through, and say OK. All right, so now what we have is we've got a couple of surfaces that we can use to prepare the scan. So we're going to come in here, and we've got this tool here that's called Split Mesh with Other Solid Surface or Mesh. So we click that, and what we can do here is click on the areas, the envelope that we want. We're going to go ahead so we can see here that it's splitting it with that. We're going to say OK. And we can do the same thing again. So I want to use this one down here. And there we go. We'll say OK. And so now if we come in, we can keep only that, that mesh behind. So I'll go back and close this out. So now if we hide the surfaces that we created, we're left with a mesh that has a nice clean border on it. It's much cleaner than it was when we manually cut it. We still need to do a little bit of manual trimming work here. So for example, I need to get rid of these holes. Make sure we're not using select through. Just going to draw a circle, probably a bit too big. I'm going to delete that. And we'll do the same thing over here. Delete that. And again, go into this individual bodies. We'll keep that one. Go back. I'm going to go ahead and clean up these boundaries. Do that one as well. And then we'll fill those holes. You can see it still did leave kind of this little piece here. So I'm going to measure that. Looks like about 2.5. I'll expand it. We'll fill that hole. And we'll call that good. So now we just got a hole in the top and the bottom. And for the most part, everything looks good. Maybe a little spot there we could clean up, some spots on the side. But overall, that looks pretty good. So we'll close that. We'll go to Auto Freeform. Now we're using Feature Aligned, which is, again, a different algorithm. If we want to, we can use symmetry. And this is going to be along XZ, because we use that to align the part. If you want to use symmetry, we can do none as well. And let's just go ahead and let's just take a preview of what the freeform body looks like. We'll turn analysis on. You can see this is a much better result. We actually get a preview on the screen of the freeform divisions. You can see there are maybe some, this is probably going to give us a warning. It's going to give us a red dot that needs to be fixed. But the freeform body on medium, which is the same one that we used before, is a much closer representation. So we're going to say, okay, we're going to edit that freeform body. We're going to allow it to pull those quads in, those points in those corners. We're going to show a full mesh. And then we're basically just going to go through the same process. I'm going to take these, turn off the snap mode, and pull this up above. We'll do the same thing over here. Snap mode is off, up above the part. We'll do the same thing on the bottom. Make sure it goes down below. And then here, we're going to have to do the same thing with extrapolate, and we'll pull that in. And it's a much cleaner result. We don't really have any cleanup work that we need to do. So I'll double click over here. We'll have to go back to our selection tool, go to extrapolate, and pull that. Again, what we're looking to do here is make sure that these points aren't bunching up on each other and that we're completely past the mesh. All right, so at this stage, now we've got some planes. So we've got a plane on top, and we've got a plane on bottom. We've got cylinders, so we've got this cylinder here. And you can kind of see we've got some of the features and tools that we can use to sort of cut this up. Now there are two tools that we have. We have trim and we have cut. Now, cut is generally used to remove one solid from another, but trim is actually pretty versatile. We can use it for solids and surfaces and other things. So what we're going to do is select the cylinder. We're going to select the plane that we want. So plane 1, cylinder 1, and Auto Freeform. And we're going to select the trim tool. So what this is going to do is it's going to open up a dialog. It's going to let us select the areas that we want to remove. So like the top of the cylinder, the outside of that, this little piece here, that piece on the outside we don't need, this little extra piece here. Now, that all kind of went away. This is likely due, if we reset, this is likely due because that cylinder is not actually extended far enough. So we want to make sure that the cylinder does go all the way outside. And that way we won't have that problem. So again, select the cylinder. We're going to select the plane, which is plane 1, cylinder one, and Auto Freeform, and we'll try trim again. It's going to go through and analyze all of the different options that we have. It's going to figure out which areas we can remove. So we'll get rid of that. That's outside stuff going on. Get rid of that. And again, just kind of work our way around. Depending on your inputs, this could just be a couple of clicks, but I'm going to go ahead and say okay. What we're going to be left with is all of these surfaces are going to kind of stitch themselves together as one, and we're going to have to repeat the process on the bottom. So we're going to allow it to rebuild. So now we got that. And then we want this plane, and then we want our trimmed surface. So this guy right there, and that plane. We'll use trim again. And again, it's treating the planes like a surface, which is different than how this information, if we try to export it to Fusion, that doesn't give us that option. Now, because we're creating what's called like a watertight body, this is now going to turn into a solid body where it really was just a trimmed surface before. So if I hide the meshes, you can see what we're left with here. This is a much better result. Looks a whole lot better than what we had before. We do have a couple of cylinders here. And if we take a look at these cylinders, again, they need to be extended so that everything fits. But what we're going to do is we're also going to talk about some of the other options with Pro where we can do things like extrude to a face. So for the larger cylinder, I'm going to hide it. For the smaller cylinder, I'm going to go ahead and use it as a cut tool. So I need to make sure that it goes all the way through the body. So we're going to select the trim surface here. We're going to say cut. And then with the cut tool, we just simply select the cylinder, which is the primitive cylinder we created, and it'll remove that for us. So again, that's why we extended it so it would go all the way through. We also have, let's go ahead and bring a mesh back. We'll hide the solid body temporarily, and we'll create a 2D sketch. I'm going to go ahead and pull this down. We'll create. And what I'm going to do is extract some primitives. Again, I'll get a straight line out of there. We'll get a straight line out of there. And then we will extend these out so they go beyond our part. Extend that out. Extend that out. And then we'll just connect the endpoints. It doesn't really matter if this isn't a true rectangle because all we're really concerned with doing. So I'm going to pull this all the way up. This bottom one, I can hold down Control and snap to that mesh directly. And then I can use it as a cut tool and allow it to cut away from that solid body. Right. So much easier because we've got direct references, direct inputs. We can snap to mesh bodies and we can directly work with that. The next thing is for this counter bore. When we created a primitive cylinder, this one here, it only stopped at the top of that fillet. And that's a problem when we go to use it to remove it. And the same thing around here, we've got a fillet here. So this is why we can use things like creating a 2D sketch. We can pull this up until we've got a good reference. So maybe right there. Let's actually go a little bit higher. And then we'll extract a primitive. We'll do a fit circle. Looks like a pretty good reference. So we'll just grab that. And we'll extrude it. All right, so again, we can pull this up. We can pull this one down and snap it to a mesh reference, turn our solid body on and use it as a cut tool. And you can see now it was able to snap down to there. So all we really need to do is add a fillet to this corner right there, and we can round it. Now, with things like this with fillets, it's a good idea to turn the mesh reference back on, and you can get a good indicator as you begin to pull this when it crosses through that mesh reference. So if we pull it too far, what we're going to start to see is that we can see the solid body through, and we can go back a little bit and make it match. Obviously, if you have a measurement of this, then you can use that. So it looks like it's about 1 millimeter to maybe 1.25 millimeters. So I'm just going to go ahead and apply that. This corner right here, we can also apply a fillet to. I'm going to create and stay. And then we'll add a fillet here. And again, kind of the same thing. We're going to just take a peek and see when we get to the point where the mesh starts to pop through. And then we know we're at about kind of the right area. So it looks like maybe 0.625. We'll apply that. And then I'll say OK to create it. So again, this is another area where using Pro can be helpful because we have direct access to the mesh. We can snap to it and we can use it for those features. So for this part, that really helps us get to the point where we can start to build out these features. I'm going to apply a couple more fillets. I'm going to go and grab all of these edges, this one here, and I'm going to add a 1 millimeter fillet. I'm going to apply it to all those edges. I'm going to create and stay. And we'll do this one here. I'll make it 0.5. Apply, create, and stay. And then we just need to take care of these sharp corners down here. I'll do this one as well. Make this 0.5. All right, so you can kind of see where the mesh is. Looks like we're matching it pretty well. And I'll say OK to create this. It probably looks like there might be one more fillet on these bottom edges. Looks like both. Probably pretty tiny, just a deburr operation most likely. And it looks like it's failing. I'll go a bit smaller. Doesn't like wrapping around that corner there. So this is most likely in manufacturing, this is most likely just a deburr operation on those corners. It doesn't seem to be liking the fillet. So what we could do is we can increase the radius of that fillet if we need to, but I'm going to go ahead and leave those corners sharp. So the last feature that we really have here is going to be the threaded holes. And we can do this pretty easily. Because those are threaded, we can't really generate a good primitive. I mean, we could generate a cylinder, but probably the easiest thing to do is just create a sketch. Now, if we know the size of those holes, let's go ahead and bring this up. Go ahead and create. And you can see that it's not a great sketch reference. So what you may want to do is hold down Alt, maybe jump over to another spot, and then we'll grab maybe that, maybe over here. And then if you know what the size of those is, you can use the dimension tool. All right, so if we know that they're both exactly 7 millimeters, for example, we could do that. If you need to change it, let's say it's 6, it will keep it centered on the location. It doesn't have a constraint locking it to that position, but it will keep it there. We can also do things like we can draw a horizontal line here. We can draw one here. And then we will turn these lines into construction. They're not needed. But then we can make sure that these lines are horizontal. So we are ensuring that these hole locations are that distance. And then, of course, you can use dimensions to give it a, let's say they're exactly 38 millimeters. And then what we can do is extrude them. Bring our solid back and bring it down to, this one's always a little tricky because it doesn't go all the way through, but I'll take it to there, cut, and there we go. So now that process was much easier to do with all the Pro tools because not only do we have access to the CAD tools directly inside of QuickSurface, but we have extra options like a better algorithm for Auto Freeform. We have the option to snap to the mesh when we're doing things like extrude. We can use tools like planes to cut surfaces and trim and cut bodies directly here. So what I'm going to do is I'm going to save this, and then I'm going to export this CAD body, and I'm going to bring it into Fusion. So we're going to export this model, and we'll save it as a step file, and then we'll hop back into Fusion, and I'm going to open that step file. So what we're going to see is a drastic difference in quality. You can see how much better this edge looks. And part of the discrepancy here is going to be because how much we reduce the number of triangles and how much we smooth that mesh makes it a bit easier to work with, especially for something like a webinar. We don't have to worry about the processing nearly as much as dealing with 2 million triangles. But we can see, just looking at this being a freeform surface is quite a bit higher quality than this. You can see when it gets to those fillets in those corners, it has a much harder time. And this all comes back to the algorithm that's used to generate that. So again, back in QuickSurface, if we go to a mesh and we go to, actually, let's go back to this mesh. We go to Auto Freeform. The basic algorithm is the one that you have in the LITE version, which can do okay for basic shapes if you're not getting into too much of a complicated geometry. If the mesh is fairly clean, you don't have too many triangles or overlapping triangles or things like that. Feature aligned is the option or the algorithm that we have available with Pro. Does a much better job, and it has more options. For example, feature details. We can do higher feature details if we wish. We could even do Auto Freeform for the entire model, and it does a pretty good job. We have improving hole boundaries. We can draw guide curves if we want specific areas for those freeform edges to be. And we can also make use of things like symmetry planes. So if we create a symmetry plane, we use that to align it to our coordinate system. We can then make use of symmetry, which is going to give us, essentially what's going to happen is the freeform result, let's go ahead and hide the solid body, but the freeform result in this case on the XZ plane is going to allow that freeform model to have an edge there. And you can see that it's essentially symmetric from left to right. So again, this gives us much higher quality results. We can see there is some discrepancy here because the model isn't perfectly symmetric, but we can go ahead and turn that off as well. We can do a higher level of detail. We can increase the number of quads. We can allow it to calculate that. And this algorithm is just so much of a step above and beyond what you get with LITE. And that's why it's important that we understand the differences. Again, you can see from the analysis here that this is much better. There's a small hole here, likely due to an inconsistency with the mesh. But if you're trying to use an Auto Freeform tool and you're trying to generate complex shapes, when we talk about things like car fenders or bumpers or geometry that is fairly broad, doesn't have a lot of high changes in curvature quickly, then the basic algorithm can do a decent job with that. When we start to talk about trying to wrap a freeform model around something like this, this is where you really can see a big difference in Pro over the basic tools that we have in LITE. So again, just another quick recap. Creating a sketch that can be used for cutting the mesh, that's available in Pro. That can also be done with solid bodies, surfaces, or planes, so we can use all of those to cut a freeform body. So those are available in Pro, not available in LITE. We have the ability to use things like the Auto Freeform tool with symmetry. If we need to, we can draw lines on the boundaries to help guide where we want those freeform divisions to go. And we can also do some additional options with those Auto Freeform tools that we don't have available to us in LITE. We have access to more CAD tools. We can do things like trim and cut. Those aren't options in LITE. We can build all sorts of primitives and surfaces in LITE, but then we have to export all of those as intermediate CAD data and work with them in another program like Fusion. We can also do things like extrude and snap to a mesh. Those features are not available to us in LITE, but they are available to us in Pro. So if you need to extrude up to a reference mesh, then that option is only available to you in Pro. Now, there are other different options. There are other different features available in Pro that aren't available in LITE. But in terms of this specific workflow, those are some of the major ones, the differences that you would see. And I would say probably at the end of the day, the biggest difference is in the quality of the result. So the quality of the result that you get out of the patches that we create in the Pro version are just above and beyond anything that we see come out of the basic algorithm that we can create the part in LITE. So now's the point where if you're on the webinar, we're going to go ahead and start to talk about some questions. If you're following this on the YouTube videos, then if you had any questions, you can obviously leave those in the comments. Remember that we are an affiliate, so if you are looking to purchase QuickSurface Lite or Pro or QuickSurface for SolidWorks, you can use the code LEAD10 at checkout. That will save you 10%, and that does help out the channel. So if you have any questions on this, please leave comments, let us know. If you want to see more QuickSurface content, let us know that as well. As always, thanks for watching, and we'll see you in the next one.